Okay, hello. So today we're going to do day 6. We're going to do equations of normals. So first of all, what's a normal? It's a line, okay? It's a line that goes perpendicular to the slope to the tangent, okay? Remember what the tangent is? That's your line that goes against the curve, and the normal is one that is perpendicular. So remember that slope relationship, they're negative reciprocal. So if you have, for example, the slope of being 1/3 of the tangent, then your slope of the normal is, you're going to switch the sign and flip it. So it would be -3 or -3/1. Okay, so let's find the equation of this thing. It's almost the same thing as the equation of a tangent, just perpendicular to it. So we've got find the equation of the normal of this function at a point where x equals 1. So I've copied this here because I'm artistically challenged. So at x equals 1, then we are somewhere here. This would be the slope of the tangent. And so what we're asked for is we're asked for this slope of the normal. That's our normal line. Okay, well, remember what the derivative is. It all starts with a derivative. The derivative is an expression for all the slopes of the tangent, right? So what we can do, and actually, I didn't even have to take the derivative because it's at a specific point. So what I can do is I could just go to 1, and then go to function, go to slope, and be done with it, okay? So if I sub it in, you can check. It would be, there's your 6, 1, 3, it's 9, okay? So again, what is this 9? This is the slope of the tangent. So therefore, your slope of the normal is going to be negative. This is 9/1, -1/9. Since it's the equation, what we're going to do now is we're going to do exactly what we did with the tangent. Remember, we need a slope. There it is. And we need a point. So we have the x part of the coordinate. And then to get the y, you know how to do this. Just go to num, see what's happening at 1. It's 3, and that's our point, okay? Now you can just do point slope form. So you can do y -3, or if you insist, you can do mx plus b. You would get the same thing. But I'm going to stop here because, yeah, we don't have to go any further. Okay, the second one's a little bit trickier. So the gradient of the normal to the curve at the point 1b is -1/4. So this is the slope of the normal. Solve for k and b. Alrighty, so you have some unknowns. Let's see if we can figure this out. Slope of the normal. I don't know. No idea. Let's take the derivative. So this is 3k x squared minus 2. Again, what did we find? We find all the slopes of the tangent. So they gave us the slope of the normal. It's just of no use. So why don't we instead find the slope of the tangent? Since the slope of the normal is -1/4, then the slope of the normal is going to be +4. Yay! Okay, so since this is all the slopes of the tangent, we know that this is happening at 1, and we know that the slope is 4. Remember what this is? This is an expression for all the slopes. So what we're going to do is we're going to set the derivative when x is 1 equal to what the slope is at 1, which is 4. Ta-da! And of course, now we can solve this. So 1 squared is just 1. So this is just 3k minus 2 is 4. And then you can just finish it. You can also graph it, divide by 3 on both sides. K is 2. Okay, so what does that mean? We're not done quite yet. We now know. And if you want to, remember, it's much better for your learning to do this interactively. So just pause it, try it. Okay, this is your actual function. Now, well, what are they asking us for? They're asking us for, like, what's the y when x is 1? Okay, this is like not a drama. Just graph it. Coincidentally, it's also 2x cubed. Haha, 2x cubed minus 2x, and then plus 1. And then at 1, you can see that you're at 1. And so therefore, your b is 1. It might look easy, but these questions tend to be more difficult for you people. So just make sure that maybe you have it go at this a couple of times. Right. Okay. So again, when you take a derivative, that's the slope of a tangent. Go to the normal by doing the negative reciprocal. And from there, the equation is the same. Bye. Tschüssi.